Okay, we're going to go ahead and switch gears now and talk about Part B of the final review. This is page 7, problems 1 through 6. So in terms of the problems that we have, the first one is probably going to be the hardest. It says in 2001, 408 teenagers underwent gastric bypass surgery. And in 2003, 771 teenagers underwent gastric bypass surgery. We want to use this information to write a linear model for the number of teenagers having gastric bypass surgery since 2000. So this is going to be find a linear equation. So the first thing that we need to do is we do need to go ahead and find the slope. So let's go ahead and start by finding our 2 points. Our 2 points are going to be 2001 is 1 year after 2000. So it's going to be 1, 408. And 2003 is 3 years after 2000. So it's going to be 3, 771. So if we plug into our slope formula, which is y2 minus y1 over x2 minus x1, we get 771 minus 408 over 3 minus 1. We are allowed a calculator in this section, so we're going to go ahead and use our calculator to calculate that out. I get 181.5. Okay, that is the slope. We still need to finish finding the equation of the line. So we're going to use our point slope form. Our point slope form is y minus y1 equals m times x minus x1. I'm going to work with the first point here. When we plug in, we get y minus 408 equals 181.5 x minus 1. If we go ahead and distribute now, we get y minus 408 equals 181.5 x minus 181.5. And now if we add 408 to both sides, we get y equals 181.5x plus 226.5. Now the last thing that we want is, did I want x as my variable? And the answer is no, we wanted t. So if you want to, it doesn't give us a variable to use instead of y, but we do need to replace x with t. If you want to use something else for y, you can go ahead and do that on here. So this is our equation. Okay, the last thing we want to do is, according to our model, we want to know what is the number of teenagers having gastric bypass surgery in 2006. So let's go ahead and plug in our t value for 2006, t will be equal to 6 in that year. And if we plug it in, we get y equals 181.5 times 6 plus 226.5. If we go ahead and multiply, we get 181.5 times 6 is 1089. If we add on 226.5, we get y equals 1315.5. I'm going to go ahead and round that up to 1316 teenagers. So one thing to note on this problem, make sure that you're very careful. Make sure that you don't assume that you are given a y-intercept. It's not necessarily going to be the case. So make sure that that's the important thing. Pay attention to whether one of your points is the x-intercept or not. Do not make assumptions. All right, let's go ahead and try another one. It says, according to the Nutritional Sciences Department at Penn State, a woman's weight is 100 pounds at 5 feet, and her optimal weight is 130 pounds at 5 feet 6 inches. We want to use this information to write a linear model for a woman's optimal weight in pounds based on the number of inches her height is above 5 feet. So for part A, we want our 2 points. So if she is at 5 feet, how many inches above 5 feet is that? That's going to be 0. And her optimal weight is 100 pounds. At 5 feet 6 inches, that is 6 inches above 5 feet. And we have her optimal weight is 130 pounds. So now if we go ahead and plug into our slope formula, we get 130 minus 100 over 6 minus 0. This is equal to 30 over 6, or 5. Okay, now if we plug into, do we need point slope form on this problem? And the answer is no, because if you look here, what is this point? This point is the y-intercept. So we can actually go ahead and jump straight into our slope-intercept form. We get y equals mx plus b. And so when we plug in, we get y equals m is 5 and b is 100. Okay, so let's look at part B. We have, according to our model, what is the optimal weight of my math instructor if she is 5 foot 8 inches tall. So for this one, we have 5 foot 8. This is going to translate into x is 8. We want the number of inches above 5 feet. So if we go ahead and plug that in, we get y equals 5 times 8 plus 100. 5 times 8 is 40. Plus 100 equals 140 pounds. Now this one of the things that we saw was that the y-intercept was given to us. Again, be very careful when you do these because it is not guaranteed that you are going to be given a y-intercept on the final exam. Hint, hint, hint. Okay, for example 3, we have d of t equals 650t plus 8400 represents the tuition d dollars at a college for the year that is t years since 2000. We want to find an inverse function for this model. So the first thing that I'm going to do is I'm going to replace d of t with just a d. Now, when we talked about inverse functions, we said our next thing to do was to replace, or was to flip our variables, meaning d would become a t and t would become a d. We only do that when we talk about x and y's, because x and y are our generic, they don't have any special units associated with them. Since we are working on a word problem, d represents dollars. T represents time. And so we do not want to switch our variables because then we're going to switch up which letter represents which. So we're going to leave it as d equals 650t plus 8400. We want to solve for t in this one, so we're going to subtract 8400. We get d minus 8400 equals 650t, and then we can divide by 650. We don't need to do anything else to this. We can't simplify it, so we're just going to leave it just like this. So my inverse function is now going to be t of d. D is now my input. And we get d minus 8400 over 650. Now for the second part, it says find the year when tuition was $9,700. So 9,700 is a dollar value, meaning that it's going to go in for D. Whether you choose to use the original function or the inverse function doesn't matter. Okay, so if you're stuck on finding the inverse function, note that you can plug this back into the inverse function or the original function. You just have to make sure that wherever you're putting it in for D. I'm going to use the inverse function. I'm going to replace my D with 9,700. $9,700 minus 8,400 is 1,300. And if we divide by 650, we get 2. What is this? This is years. And we do want to continue. It says T is the years since 2000. So in 2002, our tuition will be $9,700. Now, if you choose to go into the original function, note that you're still going to have to do all the same solving process. You're still going to have to subtract 8,400. You're still going to have to divide by 650. And so you should get the same answer no matter what. Okay, let's try one more just to make sure that we got it. We have the A&E Toy Company has a profit of P of D equals 4.5 times D minus $300 when D is dolls sold per month. So again, the first thing that I'm going to do is I'm going to replace P of D with just P. And remember, D represents the dolls, not dollars. P represents our dollars. It's our profit. Okay, so in order to solve this, we're going to add 300 to both sides. And we're going to divide by 4.5. Again, I can't do anything to this. We can't simplify it. We're going to leave it just like that. But we are going to want to put this in function notation. And my inverse function is going to be D of P. Remember, P is now my input. So we get D of P equals P plus 300 over 4.5. Okay, find the amount of dolls needed to produce a profit of 20,000. So we're going to plug in 20,000 into either the original function or our inverse function. For this one, I'm going to go ahead and plug it into my original function just to show you that it doesn't matter which way you go with this. If we plug it into the original function, remember this is our profit. So this is going to be 20,000 we are looking for dolls. Sorry. Got a little carried away there. This should be minus 300. So in order to solve for D, we add 300 to both sides. We get 20,300 equals 4.5D. And if we divide by 4.5 to both sides, I get an estimate. I'm going to have to round this. I get 4,511 dolls. If you plug this into the inverse function, notice that we are doing the same thing. It's just a matter of whether we're looking at two sides of the equation or not. How do we solve for D? We add 300 and then divide by 4.5. Okay, so that takes care of problems 3 and 4. The next one we're going to look at is a quadratic function. It says an outlet electronics store has calculated from past sales data the revenue from selling refurbished iPod Nanos. The weekly revenue from selling these refurbished Nanos can be modeled by R of n, where equals negative 1.5 n minus 60 squared, plus 5,700, where R of n is the weekly revenue in dollars from selling n refurbished iPods Nanos. So pay attention to your variable. So n is our refurbished iPod Nanos, and R of n is the revenue in dollars. Okay, so we want to know what is the weekly revenue from selling 50 refurbished iPod Nanos. So is this an N or an R? This is going to be an N value. So in my function, I want to replace all N's with 50. And if we simplify, we want to use order of operations. So we get negative 1.5 times negative 10 squared plus 5,700. Negative 10 squared is 100, positive 100. Negative 1.5 times 100 is negative 150. And if we simplify that, we get $5,550. For Part B, it says find the maximum weekly revenue and how many refurbished iPod Nanos must be sold per week to make the maximum revenue. So maximum, when we ask about maximum, this is what is the vertex. So what is our vertex? Remember that since this is in vertex form, we're going to change the sign of the first one, the inside number, and we keep the outside number. So the first one, this is the N value. The second one is my R value. So we need to sell 60 iPod Nanos must be sold. And our maximum revenue will be $5,700. And we're done. Okay, last problem, we're going to look at something similar. We have the total fresh vegetables consumed per person per year can be modeled by the function v of t equals 0.7 times t minus 1.5 plus 95.4, where v of t is the total fresh vegetables consumed per person in the year T since 2000. We want to find V of 6 and explain its meaning. So we want to plug in 6. We get 0.7 times 6 minus 1.5 squared plus 95.4. All right, if we go ahead and do this, we're going to go ahead and simplify inside our square. We get 4.5 squared plus 95.4. 4.5 squared is 20.25. If we multiply that by 0.7, we get 14.175 plus 95.4. Which gives us 109.575. We want to round our answer to the nearest integer. So this is approximately 110. We're going to round up because it's a 5. Now it does say round, it says explain its meaning, so we do want to interpret this. So in 2006, we do have 6 years since 2000. That's going to be 2006. The consumption of fresh vegetables was 110 vegetables, I guess, per person. No, that is pounds. I finally saw it. 110 pounds of fresh vegetables per person. Okay, for part B, we want to know when the minimum intake of fresh vegetables per person in pounds occurred and what the minimum intake amount was. So this is going to be our vertex. So remember our vertex, we want to change the sign of the inside number. So this is going to be 1.5. We keep the outside number. It is going to be 94.4. So the when we're going to say sometime between 2001 and 2002. The how much, the maximum or the minimum intake, was 95.4 pounds per person. I encourage you to check the answer key on this one just to see if they want it to be 2001 or 2002. My assumption, I would say go with the 2001 because it actually does happen in 2001. It does not happen in 2002. But the best way to put it is between 2001 and 2002. All right, so that takes care of this page. Take a quick break and we'll come back and look at the next page and the last page.